Hello students, I am Dr. Navneet Kaur from Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology College. Today I will be taking lecture of subject Signals and System. The topic which I will discuss in this lecture is signals and its classification. Now first, we will see what is a signal. A signal is a quantity which contains some information. It can be a function of one or more variables. It can be expressed as function of, say, any variable, say time t1, t2, or can up to tn. Each of the tk is called an independent variable, while the function value itself is known as dependent variable. Now, some examples of signals which we face in practical life include the voltage or current in an electronic circuit, position, velocity or acceleration of an object, force in a mechanical system, a flow rate of a liquid or gas in a chemical process, a digital image, digital video, digital audio signal, or a stock market index. Now, signals, as I have already discussed, are functions of independent variables that carry information. Now, signals can be electrical signals like voltages and current signal in a circuit. It can be acoustic signals, which are audio speech signals, or it can be video signals, which depends on the intensity variations in an image. Now, signal is a quantity which depends on variable, which is independent variable. Now, this independent variable can be continuous, it can be discrete, or it can be one-dimensional, two-dimensional, or more than two or three dimensions. Now, continuous time signals. Most of the signals which we see in the physical world are continuous time signals. Continuous time signals are the signals which are defined at every instant of the time period, which is an independent variable. Like here we can see a signal is shown xt, which is dependent on independent variable time t. Now here the function which we have drawn here is a continuous. That means it can be defined at every instant of time. It can be voltage or current, pressure, temperature, or a velocity signal. Now, to convert any continuous time analog signal into discrete time signal, we will do the sampling of the continuous time signal. Now, sampling means that we will take out the samples of this continuous time signal at regular interval of time. Now, here we can see the first sample which we have taken of this continuous time analog signal is at t is equal to 0. Now, say the next sample will be taken at t is equal to, say, capital T. Then the next sample will be taken as t is equal to 2 capital T. Then t is equal to 3 capital T. Similarly, on the negative side, the samples will be taken at t is equal to minus t, t is equal to minus 2, t is equal to minus 3, t, and so on. So here now signal will be discrete time signals. That means here the signal will be shown in the form of the samples, and the interval between the samples is uniform throughout this time variation. Now, this discrete time analog signal, which is sample signal, can be converted into digital time digital signal by process quantization and encoding. Now, the quantization is the process through which we can approximate the sampled value to the nearest integer value. Now, say if I have the sampled value at 4.1 volt or 4.3 volt, I can round off to the nearest integer value, say 4 volts or 4.5 volts. So here the signal will be quantized to the fixed integer levels. And now I'll assign all these quantized levels a specific code through a process encoding. Now, using this, I have divided this my signal into different quantization steps. each quantization step or level is assigned a fixed encoded level. Now, if I'll say I have any sample at this point, now I'll approximate it to the nearest quantized level, say this red line. Now, this sample value will be given the encoded value corresponding to this quantized level. Say if this quantized level is having a code, say 0, 1, 0, 0. Then this sample value will be encoded into the form of ones and zeros and will be assigned a code 0, 1, 0, 0. So in this way, a continuous time analog signal is converted into discrete time analog signal through a process of sampling. Then it is converted into discrete time digital signal through quantization and encoding. Now, we'll start with the classification of signals. Now, signals can be continuous time and discrete time signal, which I have already discussed. It can be even and odd signal, periodic and non-periodic signal, deterministic and random signals. Now, continuous time signals, I have already discussed in my previous slides. We'll just have a recall of this concept, that the continuous time signal is defined at every instant of time. Say it is voltage signal or can be velocity signal. It is denoted by xt, and which is dependent on this independent variable t. Discrete time signal is obtained by sampling of this continuous time signal, which is defined at only discrete instance of time. Now, for example, daily stock price or the temperature at a fixed interval, say after every 1 hour of any day. Now, it is denoted by xn, where n is always an integer and is a function of time. Now, this sample signal is denoted by xnk by sampling of the continuous time signal. Now, coming to even and odd signal is symmetric with respect to the y-axis. That means if I have any signal ft, then f of minus t is equal to f of t. That means whatever is the value at t is equal to 1, the same value of the signal will be at f of minus 1. Similarly, odd signal is antisymmetric with respect to y-axis. It is written as f of minus t is equal to minus f of t. That means the magnitudes of the signal at positive 1 or negative 1, t is equal to plus 1 or t is equal to minus 1 will be same, but the signs will be opposite. If it is positive on t is equal to plus 1, then it will be negative on t is equal to minus 1. Similarly, for t is equal to 2 and minus 2, t is equal to 3 and minus 3, and so on. Now, coming to periodic signal. Periodic signals are the signals which repeats itself after a specific period of time. It has the property x of t is equal to x of t plus t, where capital T is the fundamental time period of a signal. That means the signal repeats itself after this fundamental T, capital T, which is greater than 0. Now, the examples of periodic signals are cosine signal and sine signal, which repeats itself after a period of 2 pi. So, these both signals are periodic with period 2 pi. Here we can see this is a sine signal. It repeats the fixed pattern from here to here after a period 2 pi. Then again it will repeat this pattern after a period 2 pi. Now, non-periodic signals, they don't repeat itself after a specific pattern. They may be considered like a periodic function with an infinite period. That means the pattern can be repeated after an infinity. Now, for example, I have any noise signal, sound signal, say I have exponential signal, I have a ramp signal, in which the pattern is never repeated in the signal. Now, for any two signals, x1 and x2, say I have any signal y, which is made up of the sum of x1 and x2, where x1 and x2 are both periodic with time period t1 and t2. Now, this signal Y will be periodic if and only if the ratio of their time period T1 by T2 is a rational number. That means it should be a ratio of the integers. Now, T1 by T2 should be Q upon R, where Q and R are integers and co-prime. Then the fundamental period of Y will be RT1, or we can say QT2. Or it can be obtained by LCM of T1 and T2. Now, coming to even and odd signals, I have already discussed that even signals, they are symmetric with respect to y-axis, whereas odd signals are anti-symmetric with respect to y-axis. Now, every signal is made up of even and odd components. So, if I have signal xt, it can be represented as sum of even component xt and odd component x naught t. Now, this even component xet is given by sum of xt plus x of minus t divided by 2, whereas odd component is given as xt minus x of minus t divided by 2. The even and odd components are often denoted as even of x and odd of x respectively. Now, for an even signal, I have already discussed it is x of minus t is equal to x of t, which is the commonly example is cos t. Odd signal is identical to its negated time reverse signal and it is equal to the negative reflected signal. So x of minus t is equal to minus x of t. The most commonly used signal, which is an odd signal, is sine of t. Now, coming to energy and power signal. The energy contained in any signal xt is given by the formula integration minus infinity to infinity xt whole square dt, where xt is taken as the magnitude form, so absolute sign is used. Now, if I have any discrete time signal xn, then in place of integration, I'll have summation sign with limit n is equal to minus infinity to plus infinity, xn, then magnitude square d. Signal which is having finite energy and zero average power is known as energy signal. Similarly, the average power contained in the signal xt is given by limit 1 upon t, where t is the fundamental time period of the signal xt. T tends to infinity, integration between minus t by 2 to plus t by 2. That means over one time period. Then xt magnitude square dt. Similarly, for discrete time signal, I'll have summation sign in place of integration and I'll have capital N, which is the fundamental time period of xn. So I'll have formula limit n tends to infinity 1 upon n, summation n is equal to minus n by 2 to plus n by 2, xn magnitude square. A signal with finite average power and infinite energy is said to be a power signal. Now, this is all for today's lecture. Thank you.